Hello and welcome back to another session of Getting into Good Oxide. Welcome back, Sydney.
Hello, hello.
Now my camera froze, it seems, which isn't that much of a problem.
Yeah.
But let me fix that real quick before we continue. Last session we were on a roll, even though we couldn't record it due to technical difficulties. This time we try again. But long story short, the loose object database now has docs to still be written apparently, but also lookup prefix function. Yeah, maybe if you feel like it, we can give it a go at explaining what there is. That might be interesting to people.
Absolutely. Yeah, I mean, so the loose object database is essentially just files lying on the file system, and they all have this 2-character directory. That is essentially the first 2 characters of the hex SHA, and by that we can already kind of filter out in which directory you have to look at for the prefix, and then from there it's just iterating through the files and doing the usual prefix check that we've already implemented for the other 2. And yeah, I think that was pretty much all.
Yeah, I think so too.
There was this one extra error case we had to deal with because like you said, the file lookup in itself can go wrong, or like the file iteration. So yeah, there's one extra result in our return type now, but otherwise the rest should be kind of the same.
Oh yeah, this one here. The result option, prefix lookup result option result effectively. And it's real, it's something that you need. Which also means that at our best, we return okay some error. And okay some okay with the actual object ID, which is also different. Like this lookup result looks the same as the one in the index, but as return value, there's the actual object ID that we found non-ambiguously in the set of files in a particular directory, which is really helpful that we only have to look in one directory always. There's never more than that because of the requirement for prefixes to have at least 4 bytes or at least 4 hex characters. So the first byte for the objects directory here is always present, plus 1 byte more for some disambiguation. And yeah, I think also worth highlighting is that the test that we wrote actually found a bug that we didn't really see before because it's related to error handling. So it's very possible that our iteration returns an error the first time we actually try to iterate the directory, which is because it's kind of lazy, because it's possible that the directory we want to iterate is not even there, which is valid for Git. These object directories, they do usually exist, but they don't have to exist. It's not that this would bother Git, it would just deal with that. So now do we.
Yep.
And besides that, it's actually even simpler code than before, because we really just find a candidate that is equal to it, and we hope we just find one, and if we end up here, then this means our iteration is done, and then there may or may not be exactly one candidate, and this is what this wonderful code does with map OK to turn an option into an OK unconditionally. Whereas here, if you already found some candidate, this means that we are in this case where we are ambiguous. So there's more than one object leading to this beauty. So
just looking at this code actually though we are only breaking out early if we find ambiguity, right? But is there a way to also break out early essentially if we don't find ambiguity but have a candidate? Because at the moment it's still running through all of the files, right?
That's a good point. Because after we have a candidate, then only kind of the next, it's either the next object, right, and or none that also have the same prefix. And if the next object has the same prefix, then we know there's ambiguity and we abort. Otherwise, we don't. So the candidate, yeah, we can just, no wait, we have to look one more. We have to check one more. So once we are here, we have to check one more and only that. And we can basically do that right away. Cool. Let's implement this. First of all, oh yeah, test lose. I think that's some intermediate target for testing that we've created just to test loose database. The loose object database, which includes our ones. Test ran here. So here, lookup prefix, there's a bunch of tests that all work, that's nice. And now let's refactor this one. Yeah, how to do that? How can I then ask for one more and basically redo the same check to avoid running through all of them?
I mean, you can essentially always break if we find a candidate, right? And then in this if branch, you can check the next one, the next iteration, and then return a value based on that, right?
The thing is, I can't return the next iteration because of this. This consumes my iterator.
Oh, yeah, right.
So I can't access it anymore inside of the loop. I can only go through it or break out.
Is there some fancy way to iterate two values at a time?
Two values at a time, you could, but there isn't really two values at a time because it's always just one at a time and you just choose to keep two at the same time in memory.
Yeah.
There is the possibility of peaking. You can have a peakable iterator, no problem. Then you can see what's next without consuming it. However, also requires access to a single directory iterator, which we simply don't have. I mean, this one isn't there, and probably this squiggle here tells you. Yeah. So that needs to be fixed first. How to do
then
that?
just using the iterator in a way that it doesn't consume it, just as a looking at references essentially.
By ref. Let's see if that does not consume it. Let's see. So can I now access it? Still not really interesting. The thing is, even if I find a way to put it into this for loop without consuming it so it's a moved value, it will still be currently borrowed as mutable. Like whatever we do, right? Because this for loop has hold of it and it has exclusive hold on it.
And reuse it within an iteration of the loop.
Yes, we can't. Not in a for loop. So how can we break this for loop up into its smaller pieces, which is really just calling next on an iterator, right? Calling next on an iterator until it returns none. This is what we want, and then we can do out of loop calls to next as well, because the while loop doesn't keep a reference on it.
I mean, you could probably rewrite it as to use one of the iterator functions, like for each, that actually consumes, or a while, okay.
While at some OID be single Bluetooth. Next. Okay. And this is how you can break this up, and now it has the same result.
Right.
It's looping over everything. But now I should be able to do something here. And then we don't even need to keep the candidate anymore. Here this would just naturally be none if we get through all of the items. It's okay, none. And now we have the first one that is then the candidate. And now, oh, look at this. Yikes. This not found probably doesn't happen anymore, but the IO error would happen. But the good thing is we can shortcut this. So now I think we can. Next candidate, and next OID is single directory iter next. And that could be none. Now we have to deal with all of this here.
Mm-hmm.
Then whenever this happens, I'm thinking, is there a smart way to do this? But usually, you know, it's a bit of a waste. You can start with that and then maybe you see a pattern emerge. Then you don't have to think, just match on it. So if it's none, we definitely have our candidate. Then it's okay. Some OID. Because there is nothing that could come next. And then we have a next OID result, really. We can just break this up like this. So instead of doing all this matching here, this matching just tries to find this particular case. And that's directory not found. And in the moment we are here at all, we already know the directory is there. We will not get this kind of issue otherwise. So this is why I can just abort here. Or at least I'm pretty sure I can. With our 6 or 7 objects in the test database, we won't find that. We won't encounter that.
Mm-hmm.
All right. And now if this matches too, then we are in trouble. Next OID. Yeah, you know what? Let's do it like this. If that's also equal, then we are ambiguous. Otherwise, we can do it like that. Okay. What's the problem now? Oh yeah, it's okay, some okay. Previously we already had the candidate wrapped in a sum. This is why we could map it and it kind of hid away this monstrosity. Now we have both monstrosities right next to each other, which is more interesting than it was before. Okay. So let's see if that works, huh? And then we can see if we can make this better so that these cases here, they're kind of
Consolidated somewhere.
Yeah, maybe this can be more functional. Okay. Match arms with incompatible types because of this. Okay. Oh yeah, because this one is not returning here. Yeah. So I think I got the return position wrong. We can just do it on the very top. Because every match arm here returns something.
True.
And every arm generally returns something. Cool, there's a child crying, but it's not mine, so all good. Yeah, it still works. That's nice. Cool. Refactor. Okay. Yeah, great find there. Really amazing. I looked at this before and I didn't see anything unusual, but if you know the data, right, then you are able to deduce that in fact after a while it makes no sense anymore because you aren't going to find. Oh, wait.
No?
This would be nice, but I think it's wrong. You know why? Tell me why I think it's wrong, unfortunately. What is the assumption here? Which is true for indices, but not for file-based iteration.
Oh, that they're sorted. No,
Yes.
They have to be sorted, right?
But they're not sorted here. And they don't have to be sorted. Right, so the first...
Okay, but then the previous example also... Oh, no, you're right.
Let's check out the previous one. The previous example would abort early if it found a duplicate or another match. So then it can abort because it knows there is no reason to continue.
Yes.
But that's why you have to continue. You have to make sure that there is no possibility anymore for ambiguity inside of that directory.
Yeah, that makes sense, of course. If they're not sorted, then this is not going to work,
Yeah.
And you can't sort them because it's being loaded lazy, essentially, for every step of the iteration.
Yes. You could sort it, but then you didn't save any I/O. You just used more memory because now you load all that into a vector, which has to grow dynamically. Then you sort it, and then you bail out early, but you save comparisons, so to say, but not really because the sorting also does comparisons. So yeah, you probably don't save anything. You just pay for that. So this is why I think that is it, unless it can be refactored to be nicer. Yeah, maybe the best we both see, I guess. Sometimes you don't see the obvious. To me, it looks pretty okay. I still can't do it better, but it's okay. Just a couple of lines. So yeah, too bad. I really bought it. I really wanted it. Oh. It's another benefit of doing a recording. I think without the recording, I would have not phrased it explicitly what happens, and that got me the idea that it must be sorted in order for this to work. So what I'm saying is maybe when doing dev work, you should always record it or talk to a imaginary audience so that you get to find these kind of issues more easily.
Yeah, go slow enough so you can actually think about everything.
Yes. Or explain everything. I think that really helps explain everything. Okay, cool. So now it's basically like having written it in the episode that is missing. That's great. Let's quickly get the docs from somewhere. Where is index? Let's see if we can adjust that. Then this is actually done. Then we can move on to the object database implementation, which should be the last thing needed to get short IDs working. Gonna prefix, find an object that matches it uniquely within the loose object database within this loose object database. If there's more than one object matching, okay, some error is returned. Finally, if no object matches, the return value is okay none. The outer result is to indicate errors during file system traversal. Yeah, that's it. Has okay some okay ODB. Yeah, okay, I think that could be the documentation. Anything that's obviously wrong, typos or something missing, maybe something you would add, remove, adjust.
Looks pretty good.
All right. Good enough for first version. Docs to lose store lookup prefix. Okay. Whew, now, how to add this to the object database? Yeah, I think I would need a refresher. Like, because now we've been working on lookup prefix, which seems so low level, and it's really tied to one particular thing. And I forgot how this is actually used in Vergen.
Yeah.
And now this is what we will have to implement. So let me open Vergen, because there we use it already, or there we see how GiG-23 is used. I think that's the function that is used under the hood. Short ID. Oh yeah, so. Wow. Lots of red, ignore. So in order to get a short ID, what's this? That's the shortcut to get access to git ref parse, right? Like here, git ref parse head. This just gives you the current commit at head. And we did that earlier already. Also, the Git2 code did that earlier by peeling to commit and something like that. And that's doing the same thing effectively. It's just an easier way to do that because you don't have to deal with all the nitty-gritty. Maybe this is how future users of Git Oxide will also be doing it. Just give me whatever commit this or whatever object this points to. It doesn't have to be a commit, by the way. So it's not equivalent to this, I believe.
Yes, but I'm guessing the ref parse function has a lot more functionality, right? You could probably a lot of different things you could input there.
Yes.
And it would still resolve.
But I think you are able to even specify that you want to commit by doing something like this. See, it's the same ID. It's a commit, but if it wasn't a commit, this would not work because this gives me the first parent or something like that. This is also working. This is the zero's parent, right? So if this wasn't a commit, you couldn't interact with parents of a non-commit. And this is, I think, how you can validate that it's a commit. Or a commit-ish, because it just would try to convert that into a commit. So that would not work for a tree, huh? So can I do this? Oh, I forgot the syntax. Oh yeah, look. So that's the tree. That's the tree. And now if I have the tree and I try to get the zeros yeah, do the same thing, it should tell me that it can't do it. And if you remember this tree, I'm now digressing a little, I know, but I'm interested in seeing how this works. So now, see? So in order to do what they do, you would want to do this. And then it's equivalent. Then you know you get a commit.
Make sure. Yeah.
Funky. Yeah, funky and cool. Or if you like that more, same thing. I'm a bit, that's the first, second parent of a commit. If you have a merge commit, then this is how you can see what was merged in. But I still have trouble to understand why this works. Anyway, one day we will implement that, maybe even on video, and then we will know for sure.
We'll have to know.
We have to know, yeah. But that's going to be fun. I'm looking forward to this one. Really, it's great. I'm kind of on the track already, with short ID as a piece of the puzzle, definitely. Okay.
But I mean, yeah, they're doing the opposite, right? They're getting an object ID, and or are they getting the actual object? I'm not sure, but yeah, they're generating a short ID from that. Yeah.
Let's see. Oh, it doesn't jump there, probably because of the errors that we saw. Ref pass single. I think this should give you an ID, and for that you can get a short ID. And apparently this doesn't have any configuration, it just reads the configuration from the repository, which is fair.
You mean regarding the length of it, or?
Yes. So I think this means we have to update the task list, because we have to add this to the ODB, but also to the repository handle short ID, which is more, so this would be short ID hexlang. And this one reads the hexlang from the configuration, which it has access to. And that's a whole new topic, read configuration, we can do that, but we don't do it fully correctly yet, to the point where we probably do the right thing, but maybe not, because there's still some features missing in git config, but it doesn't matter, something to improve over time. We can definitely get here. But yeah, more work.
But the short ID function is still the reverse of what we're actually have to implement for the ODB, right? Because we still have to have, I think, this one function in the ODB that takes a short ID and then just checks across all the databases if it is ambiguous or not. And then with that, we can write the short ID function that does the reverse.
Yeah, I think there will be two. Or yeah, there will be lookup. There's lookup prefix again in ODB. You're right. Because we just want to hand it some ID with the length and then see if that's unique. If not, we increase the length. And this short ID hexlang, it could be something that doesn't even exist, or it's something that exists on ODB just for convenience, which can then be used by the repository, which just knows the default values for this. This is it, right? Like, find me the default value and pass it in, or the desired configured value. Okay, so this and lookup prefix again. And the short ID gets an object ID as well.
Yes.
And really, it's a couple like this because we need the full object ID and the desired length, and then we probably create the prefix ourselves. Because we will need the full object ID as a basis, not just the prefix, which has these portions zeroed out that it doesn't need.
And what if we just say we create the shortest possible one for the short ID?
Yeah. But I think that's more expensive. Like, first of all, I mean, it needs to be configurable. Like, this thing should not be smart. You tell it what to do and it does it. Because the one driving this has to essentially make sure it always is unambiguous. So that's this part here. And this one just executes and tells you yes, yeah, no, 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 yes, when the ID is long enough. Just looking for the shortest one is something that, you know, this would do that if the user says, give me 4. I want just 4. And then maybe that works. But I think that's how that would work. Yeah, so very similar to what Git already does. But it would be cool, you know, keep coming with these questions because maybe you find something where Git does something not in a way that is the best way or the most comfortable way. Because yes, this is ultimately also something that Git Oxide tries to do. Be better where possible. And if it's only more convenient or less surprising or something like that. All right. Cool. Then let's go for lookup prefix.
I would say so.
Okay. Already 30 minutes in, I think all that we can reasonably do without pushing over the time limit is to get some orientation on the code, maybe see what we are dealing with here, and leave it at that probably. So there is this dynamic object database, and it can handle packs, it can handle loose object databases, it can handle Git alternates. This means many loose object databases, many packs, multi-packs as well. It deals with all of that and threads and everything, and make sure it's still fast. It's a bit nuts. So in this environment, we should be able to where to put it, right? I don't know. So there are these handles, and these handles have access to a store. The store is the shared structure that contains all the information about what could be loaded as seen on disk and what is currently loaded, because not everything, it's all lazy loaded. Things are memory mapped on demand. And it has a local snapshot of the view of the world, so to say. And this snapshot contains the actual data and actual information on what's there as last seen, so to say. And on this handle, we should be able to implement lookup prefix directly. Something that we can probably use as a basis for that implementation is contains. Contains is currently coming as as part of a trait implementation for git pack find. But that shouldn't bother us. I wouldn't change the trait at all because the trait doesn't care about short IDs. Like pack doesn't care about short IDs at all. There are other find traits as well, like ODB defines its own traits here that are a bit higher level, that don't know about packs, for example. So they're easier to use. This one also has a contains and try find, and that's it, like just two methods here. We could consider adding something that relates to short IDs to this trait, because that could be useful to people, but I also would refrain from doing this initially, because right now there's really nobody who would want to use it as part of the trait. And of course that makes things more complicated, because then you have to probably implement it in other places too, and I don't know what that then does, so I'd rather not, and really just implement it on the handle itself. So that should be easy enough by copying this. Like this. So we have a handle with a store, and the store is something that can deref to a, yeah, that's kind of funny, to a superstore, to a store as defined in the module above us, and that's that item S should also be clonable, and that's the prerequisite. It should be clonable because that's a basic requirement of the handle, because the handle is also clonable. This is why. This is why this clone and this relatively specific implementation is here everywhere. I think it doesn't have to be here necessarily, because here only clone matters. But yeah, it's something we can possibly simplify here, because here for that structure it doesn't yet matter that it derefs to store, because it doesn't know, it doesn't do anything with that. But clone does matter, I think, because clone is implemented somewhere. But yeah, that's just vague memories. But this is basically why we repeat this, especially this clone, which to me is always like, do you use the clone in that impl block? If not, leave it out. Like always, don't over specify your constraints, only define constraints as you need them, because Rust is smart enough to, you know, provide you with implementations as they become available. And the less you need, the more available, so to say, this particular impl block is, depending on what the store actually can do. Since there's only one store anyway, it all doesn't really matter, because it's not really generic over the store, it's generic over the way the store is held in the handle. So the handle can deal with stores which are just references, or which use shared ownership, like reference counting, reference counted things like arc or refcell. And this is why there's this deref trait in here anyway. This is really just to generalize over the way it's shared. And that's pretty cool then, because this is used a lot throughout GiG-23 to allow using arcs for multi-threaded programs, or RCs if multi-threading isn't needed, because RCs aren't thread safe, for instance. And also to just potentially have a normal reference in here as well. That would work too. But yeah, GiG-23 always uses shared ownership for these things. That's kind of the basic assumption. It's just a question of RC or arc. And that's where this complexity comes from. Okay, so now we should be able to define something that we know by now pretty well. Lookup prefix. We don't alter, it's just reading. Even though that thing has internal mutability, mind you. So it's, again, a bit more complicated. We can get a glimpse at how complicated this is here in contains. Then we have the prefix, which is, as always, prefix. And yeah, what can be returned here? It's probably something, I'm just looking here. So whenever we access something, there can be an error. Like something can go wrong when using that data that the store provides. So I think it's more like result, option, result again. So index was really special as there was no outer error possibility here. But now I think it is again. And we see there's some top level error here that we can use. So result, option, yeah. Result, object ID, nothing. And here there is the outer error that we've seen before. Allow missing docs. Something like that. Okay. Now it finally caught up. And we have handle, lookup, prefix. Prefix, you can put that into type declaration again. Prefix, lookup, result. Same one. It's actually exactly the same one. There's nothing special about that. And it's in the same crate as well, so we can reuse it. Might as well just reuse it for now. Crate, lose, find, prefix, lookup, result. So now that looks funky because we are in crate dynamic. Are we in crate dynamic? Does that exist? Crate general? How did I call it? Crate store, I call it. Yeah. Git ODB store. So this is so like this, what I call dynamic here in the module world is exposed to the outside just as store because there's just as one store now and nothing else matters. Git store, find, prefix, lookup, result. We could move it here, then it's a bit closer to kind of the highest level one. We can say git ODB, prefix, lookup, result. We can put it on the very high level. I don't really know. Git crate prefix, crate find, prefix, lookup, result. Maybe that's where it wants to be. There's even a find here that is just full of errors, error declarations, I mean. So, yeah.
It would be fitting, yeah. General enough to be used for both use cases.
Yeah, agreed. So, that's the one. That's now my child crying. Great. Oh, okay, quick. Now, what did I want to do? Yes, I want to put that here. And then that needs adjustments. Find, prefix, lookup, result. Yeah, okay, to just fully declare it here. Short enough and good enough. Okay, cool. And that's what we will try to implement next time. A little preview. A real quick preview is that snapshot is mutable because it uses internal mutability thanks to the ref cells. And this also means this handle is only used in a thread local fashion, which makes sense because each thread, they have their own way of searching or finding objects, like their own pattern, so to say, and thus all the stuff is local to them. Each thread has its own optimized way of finding objects for that reason, because they have their own local caches. Everything is thread local, which also speeds things up because nothing is shared across threads except for that store data. Yeah, it used the snapshot data to find things in indices like before. It will always put the index that it most recently found something in, put front. That is what this swap 0 means, so that it just assumes that the next object it finds is also in that index, which can or is likely to happen if packs are built nicely. And that's what Git really tries to do, to build packs so that objects that relate to each other are co-located. Snapshot has a bunch of loose objects databases, and one of these should already have lookup prefix, which we just added, I thought. Oh yeah, right. We iterate that, it's a vector, and this one should have lookup prefix, and it does. So that's cool. We can use that. And that's the most difficult part. If we didn't find it, we can't yet give up because you might be able to load more. So this is a lazy loading part. And now we say, okay, didn't find what I'm looking for. Maybe you can load some more for me. And then it tries to load some more. And if it did, we get a new snapshot. We update our own snapshot and try the whole thing again. And if there's nothing more to load, then we know we are done. If there's an error, we should return that error. Contains can't do that, but we can because of that outer error. And that's where that outer error is essentially coming from. And yeah, that's it. So copy pasting this and making it work is probably my way to go about this. But yeah, that's the basic steps on how to interact with that object database. So you see it's a bit more involved than usual, but for good reason. Cool. Does that compile? Let's see. ODB, test that. Because if it does compile, I think then we are good for today. Just a prefix. Let's get rid of the warning. And yes, great. I think that's a foundation for tomorrow.
Oh, that's good. I'm sure I'll have a lot of questions, but we'll do that tomorrow then.
Oh yeah, we didn't even look at the tests yet. How to write tests for that so that this works. Yeah, it's going to be fun. There's a lot of test infrastructure present already, and we can just piggyback on that, I think. But let's see. Let's see about that tomorrow. So
awesome.
Thanks a lot for watching, and see you next time. Bye-bye.
Bye-bye.